What if the universe itself is not a safe place, but instead a vast minefield where every step forward could awaken forces determined to erase us? From the earliest days of human curiosity, we've looked at the stars and wondered whether life exists elsewhere. But the silence from the cosmos suggests something deeply unsettling. Astronomers call it the Great Filter, the idea that civilizations either fail to reach the stars or destroy themselves before they can spread. The very fact that we're here to ask these questions means we've survived countless trials, yet survival is never guaranteed, and history shows us that extinction is the rule while survival is the rare exception. 99% of all species that have ever lived on Earth are gone forever. Dinosaurs ruled the planet for over 150 million years before an impact changed everything in a single day. The mighty trilobites, once among the most successful creatures to crawl the oceans, disappeared after thriving for 270 million years. If dominance guaranteed safety, they would still be here. Instead, their fossils serve as a reminder that nature shows no mercy and time eventually buries everything. Humanity might believe our intelligence grants us immunity, but what if it simply makes our downfall more spectacular? The silence we hear from the universe may not be because no one else exists, but because survival past a certain stage is almost impossible. Our own world carries scars of disasters so immense that they nearly erased all life long before humans ever appeared. The Permian extinction wiped out more than 90% of marine species and nearly 3/4 of land species. Volcanic eruptions released so much carbon dioxide and toxic gases that oceans turned acidic, temperatures soared, and ecosystems collapsed. Earth itself almost sterilized life completely, and if it happened once, it could happen again. When we think of extinction, we imagine sudden catastrophes like asteroids, but often it is the slow, invisible forces that prove most lethal. Climate, ecosystems, and fragile balances hold everything together. Disrupt them enough, and the system collapses. The terrifying thought is that we might be creating our own filter, pumping gases into the atmosphere, altering oceans, and triggering the sixth mass extinction while telling ourselves we're in control. Technology may allow us to build cities, explore planets, and create machines that think, but it also allows us to damage our world at a scale that rivals ancient volcanic eruptions. If extinction is the universe's most common language, then humanity is already having a dangerous conversation with it. But perhaps the most haunting question is not whether we'll destroy ourselves, but whether the universe itself is actively stacked against us. Imagine realizing that everything we see, planets, stars, galaxies, represents just 15% of what actually exists. The rest is invisible, untouchable, and mysterious. Scientists call it dark matter and dark energy, forces so overwhelming they decide the fate of galaxies, yet we don't even understand what they are. Right now, as you sit here, dark matter particles are streaming through your body without leaving a trace. They could hold structures or processes beyond our imagination, perhaps even forms of organization we can't recognize as alive. Meanwhile, dark energy pushes galaxies apart faster and faster, perhaps toward a moment when even atoms are torn apart in the Big Rip. Our entire universe may already be doomed to end, not with fire or impact, but with everything stretched into nothingness. And these are only the cosmic threats we've discovered. Gamma-ray bursts, planet-killing beams of radiation can sterilize entire worlds in an instant, and one nearby star may already be aimed at us. Rogue black holes drift invisibly through our galaxy, silent hunters that can tear apart solar systems without warning. Even our own sun hides dangers. A single superstorm could wipe out technology worldwide and plunge us into chaos. When we look at the stars, we aren't staring at friendly twinkles in the night sky. We're staring at weapons, predators, and unknown forces, any of which could erase us tomorrow. The introduction to this story is not about comfort, but about reality. Survival is fragile, extinction is common, and the universe itself may be the harshest adversary of all. The only question is whether humanity has the will to outlast the filter that has silenced so many before us, or whether we too are simply waiting for our turn to vanish. Civilizations rise with the illusion of permanence, yet history proves that every empire, species, and structure is always just a step away from collapse. To understand the fragility of existence, we don't need to look outward into the stars. We only need to look back at Earth's own history. The fossil record is a graveyard that tells the story of dominance shattered by forces beyond control. The dinosaurs reigned for over 150 million years, longer than humans have existed by magnitudes, yet all it took was a rock from the sky to end their rule. When that asteroid struck the Yucatan Peninsula 66 million years ago, it unleashed an energy equivalent to billions of nuclear bombs. The fireball incinerated everything for hundreds of miles. Earthquakes shattered the planet, and tsunamis rolled across oceans. But it wasn't the immediate destruction that made it so deadly. It was what came after. Dust and debris blocked sunlight for months, perhaps years, plunging the planet into a deep freeze. Photosynthesis halted, plants withered, herbivores starved, and predators followed them into extinction. This was not an apocalypse designed for drama. It was a silent chain reaction where one collapse triggered another until an entire biosphere crumbled. If such a catastrophe could erase the most dominant creatures Earth has ever seen, what protection do we truly believe our skyscrapers and technology grant us? The asteroid was only one example. Long before that, Earth endured even darker trials. The Permian extinction, often called the Great Dying, makes every other disaster look small. 250 million years ago, volcanic eruptions in Siberia poured so much carbon dioxide and methane into the atmosphere that the world suffocated itself. Temperatures spiked, oceans acidified, and 96% of marine species vanished. Entire ecosystems collapsed in ways that seemed irreversible. Imagine a world where nearly every form of life disappears, where the oceans become chemical traps and the land a scorched wasteland. Life survived, but just barely, reduced to its simplest forms before clawing its way back over millions of years. The story of the Great Dying shows that extinction doesn't require an asteroid from space. Sometimes the planet itself becomes the executioner. The chilling parallel is that today humanity is pumping greenhouse gases into the air at rates comparable to those ancient volcanic eruptions. We are perhaps unknowingly creating conditions for our own great filter. Even smaller events prove how close extinction always lurks. The Tunguska event in 1908 flattened over 800 square miles of Siberian forest when a space rock exploded in the atmosphere. It was not even a mile across, yet it carried enough energy to obliterate a city the size of London. Had it arrived a few hours later, it would have detonated over St. Petersburg, and history would remember it as the most destructive urban catastrophe ever recorded. These near misses remind us that luck, not strength, is often the only barrier between survival and annihilation. Every day, Earth passes through a shooting gallery of asteroids and comets, many of which remain undetected until they've already passed. The unsettling truth is that the universe has been firing bullets at Earth since its birth, and one of them eventually finds the target. What makes these stories terrifying is not just the destruction itself, but how sudden the transitions occur. Species, ecosystems, entire worlds can thrive for millions of years, only to collapse in a geological instant. Extinction is not a gradual fade. It is often a violent and rapid transformation. For humanity, this lesson is clear. Survival is never guaranteed, and our dominance might be nothing more than a temporary illusion. We live in the briefest of windows, in between disasters, on a planet that has proven time and again that it will reset the clock without hesitation. The silence we hear from the stars may simply be the echo of civilizations that reached our stage of development, believed in their invincibility, and then discovered that the universe has no patience for arrogance. If extinction is inevitable, then the only question left is whether we are preparing to defy it, or whether we are just another species waiting for our turn. If Earth's own history of destruction teaches us anything, it is that survival has never been about strength alone, but about timing, adaptation, and sheer chance. In the silence of the cosmos, scientists see a haunting possibility. Perhaps the reason we do not hear alien voices across the stars is because most civilizations never get the chance to outlive their own great filters. The Fermi paradox, which asks why the galaxy seems devoid of advanced life despite its incomprehensible size, takes on a more chilling perspective when we consider our planet's record of extinctions. Maybe the universe is not silent because life is rare, but because intelligent life is fragile, constantly tripping over hurdles that reset its progress before it can spread to the stars. These hurdles, or filters, could come in many forms: cosmic catastrophes like asteroid impacts and gamma-ray bursts, self-inflicted wounds like climate collapse and nuclear war, or even invisible forces baked into the fabric of the cosmos itself. Each represents a trial that civilizations must pass, but history shows that most do not. For every species that flourishes, billions vanish, leaving nothing but faint traces in the fossil record or no evidence at all. When we frame our existence this way, the silence from space becomes less puzzling and more inevitable. Imagine billions of planets scattered across the galaxy, each with the potential for intelligent life. Over millions of years, many surely gave rise to creatures with curiosity and tools, perhaps even cities and machines. Yet, like the trilobites or the dinosaurs, they may have thrived for ages only to be cut down in an instant by forces beyond their control. Civilizations that burn too brightly with technology might be even more vulnerable, as their dependence on fragile systems leaves them exposed to collapse. We build vast power grids, satellites, and networks that tie our survival to constant stability, but stability has always been the rarest commodity in the universe. What if every civilization that reaches our stage of development eventually engineers its own downfall by destabilizing its environment or unleashing technologies it cannot contain? That would explain why the stars remain mute. The moment a species becomes powerful enough to shout across the galaxy, it also gains the tools to silence itself forever. But even without self-destruction, the universe itself seems to conspire against long-term survival. Gamma-ray bursts, for instance, represent one of the most violent killers in the cosmos. They can sterilize entire planets in seconds, yet they give no warning, because their radiation arrives the same moment as the light that reveals them. A thriving civilization could be erased before it even knew what hit it, leaving no chance to prepare or respond. And gamma-ray bursts are not the only lurking threat. Rogue black holes drift invisibly through galaxies, capable of tearing apart solar systems without leaving evidence until it is too late. Magnetars, neutron stars with unimaginable magnetic power, can unleash bursts of radiation that would devastate planets hundreds of light years away. The sheer number of ways the cosmos can extinguish life suggests that the odds are stacked against any species surviving long enough to spread widely. Earth itself may have already felt these blows in past mass extinctions, with some scientists suggesting that sudden die-offs were caused not by earthbound processes, but by radiation bursts from the skies. The Great Filter, then, might not be a single event, but a gauntlet of obstacles that narrow the path of survival to a razor's edge. The troubling question is whether humanity has already passed through the worst of these challenges, or whether they lie ahead. If we are past the filter, then perhaps our survival to this point is evidence that we are destined to outlast the threats and eventually colonize the stars. But if the filter is still in front of us, then the silence from space becomes a warning. Other civilizations may have reached our level of advancement only to fall victim to wars, environmental collapse, or cosmic catastrophe before they could escape their homeworlds. Humanity, for all its power, might be standing at the same precipice. The fossil record shows us what happens when species cannot adapt fast enough. The stars may be filled with the echoes of intelligent life that failed the test. The haunting truth is that survival may not be the rule, but the exception, and the fact that we are here at all could mean that we are balanced on the edge of an abyss that has swallowed countless others before us. If the possibility of cosmic catastrophes lurking beyond our control was not already enough to unsettle us, then the deeper mysteries of the universe, the ones hidden in plain sight, raise even more disturbing questions. For centuries, humanity believed it was on the path to decoding reality. We had mapped out the planets, explained the motion of the stars, and discovered the laws of gravity and electromagnetism. Physics seemed to provide a stable framework that not only explained the universe, but promised eventual mastery over it. Yet in the past century, that sense of confidence has been shattered by revelations so strange that they challenge the very foundation of what we think we know. The first of these revelations is dark matter, the invisible scaffolding of the cosmos. It does not emit light, it does not absorb it, and it refuses to interact with normal matter in any detectable way. And yet, without it, the universe as we see it could not exist. Galaxies would fly apart, stars would never have formed, and life could not have arisen. The unsettling truth is that everything we can see, stars, planets, dust, and even ourselves, accounts for only about 15% of the universe's mass. The other 85% is hidden in a substance that remains beyond our comprehension, passing through our bodies, our homes, and our planet without leaving a trace. The implications of this are staggering. Imagine studying a city by looking only at its streetlights, while being completely blind to the roads, buildings, and people that make the city function. That is essentially what human science has been doing for centuries. We have been studying the visible tip of the iceberg, while the true bulk of reality remains invisible. Dark matter, which surrounds and permeates everything, holds galaxies together like invisible glue. Its gravitational influence sculpts the cosmos, but we cannot touch it, manipulate it, or even detect it directly. And yet it streams through us at every moment. For all we know, dark matter might not be passive scaffolding, but something far more active. It could be undergoing processes, or forming structures larger than anything we can imagine. It might even harbor forms of organization or intelligence, so vast and alien that we cannot recognize them as life. If that were true, then we would be like microbes floating in the ocean, oblivious to the greater organism of which we are only a part. Even more unsettling is that dark matter is not the only invisible force shaping our fate. In the late 1990s, astronomers made a discovery so unexpected that it overturned everything we thought we understood about the cosmos. Instead of slowing down after the Big Bang, the expansion of the universe was actually speeding up. Something was pushing galaxies apart at an ever-accelerating rate, overpowering gravity itself. Scientists named this mysterious phenomenon dark energy, though the name does little to describe its nature. Unlike ordinary energy, dark energy does not weaken as it spreads. It maintains a constant density, meaning that as space expands, the amount of dark energy grows stronger and more overwhelming. Today, scientists estimate that dark energy accounts for nearly 70% of the universe, making it by far the dominant force in existence. And yet we do not know what it is, where it comes from, or why it behaves the way it does. This force is not only reshaping the cosmos, but is guiding it toward a terrifying destiny. If dark energy continues to accelerate, it will eventually overpower the forces that hold galaxies together, then solar systems, then atoms themselves. In a scenario known as the Big Rip, dark energy tears apart not only stars and planets, but the very fabric of matter. Everything from galaxies to molecules to subatomic particles would be shredded in an all-consuming expansion. The entire universe would dissolve into nothingness, not over trillions of years, but potentially within a finite timescale that, according to some calculations, could be as short as 20 billion years. While that may sound distant, in cosmic terms it is the blink of an eye. More unsettling is the fact that we cannot predict if or when dark energy might change its behavior. It could weaken, stabilize, or grow more destructive with time. Right now, we simply do not know. The combination of dark matter and dark energy leaves us with a deeply disturbing reality. Everything we understand about physics and existence is built upon only a tiny fraction of the cosmos. The vast majority of reality operates according to rules we cannot grasp, with properties we cannot measure, and with implications we cannot control. If these hidden forces can determine the fate of galaxies, then they can just as easily determine the fate of life. And here lies the most terrifying thought. What if humanity's greatest existential threat is not something visible or predictable like asteroids or supervolcanoes, but something we cannot even perceive until it is too late? The silence of the universe might not be because civilizations destroy themselves through arrogance or carelessness. It could be because the cosmos itself contains hidden traps, waiting in the very fabric of reality, ready to erase life before it has the chance to escape. In that case, the great filter may not lie behind us or in front of us, but all around us in the invisible structures of the universe itself. If dark matter and dark energy represent invisible threats woven into the fabric of reality, then gamma-ray bursts embody the universe's most immediate and violent weapon, capable of erasing civilizations in the blink of an eye. These cosmic explosions are not just brighter than anything we can imagine, they are precision weapons of nature, directing unimaginable amounts of energy into narrow beams that sweep across galaxies like interstellar flamethrowers. In the time it takes to read a single sentence, a gamma-ray burst can release more energy than our sun will produce in its entire 10 billion-year lifetime. When massive stars collapse into black holes or when neutron stars collide, the violence of the event focuses energy into jets so intense they can be detected from billions of light years away. That fact alone should terrify us. These blasts are so powerful that even across the unimaginable void of space, their signatures still burn into our instruments. The implication is clear. If one were to happen in our galactic neighborhood, pointed even loosely in our direction, Earth would not survive. The most terrifying aspect of a gamma-ray burst is its precision. Unlike a supernova, which explodes in all directions, gamma-ray bursts funnel their energy into beams that maintain their intensity over cosmic distances. It is like comparing the spread of a hand grenade to the focused strike of a sniper rifle. If one of these beams were aimed at Earth, the consequences would be swift and final. The gamma radiation would strip away our ozone layer in seconds, exposing the planet to lethal levels of ultraviolet radiation. Within moments, life on the surface would be sterilized. Oceans would turn toxic as radiation split molecules apart, triggering chemical cascades that poisoned ecosystems from the surface down to the depths. The sky would darken into a brown haze of nitrogen dioxide, and the planet would become a wasteland, not over centuries or decades, but in a single night. Humanity, with all its technologies and preparations, would not even have the time to comprehend what was happening before it was over. And what makes this scenario more terrifying is that it has likely already happened in Earth's past. Some scientists believe that at least one of the planet's mass extinctions may have been triggered by a gamma-ray burst from a distant star. The Ordovician extinction, which wiped out around 85% of marine species some 450 million years ago, shows chemical evidence in ancient rocks that could be explained by a massive influx of radiation stripping away atmospheric ozone. If true, then Earth's history already includes a warning shot from the cosmos, an event that nearly sterilized the oceans and reset the trajectory of life on the planet. This reminder suggests that gamma-ray bursts are not rare anomalies confined to distant galaxies, but real and recurring dangers that strike planets across the cosmos with devastating regularity. Within our own galaxy, scientists have identified potential candidates for future gamma-ray bursts, and one of the most infamous is WR 4, a Wolf-Rayet star about 8,000 light-years away. Wolf-Rayet stars are dying giants, unstable and prone to collapse into black holes, and WR 104's orientation relative to Earth makes it uniquely dangerous. Its rotational axis points almost directly toward us, which means that when it finally explodes, and it will, the resulting gamma-ray burst could be aimed straight at our planet. While 8,000 light-years might seem like a safe distance, the focused energy of such a burst would not care. If its beam were aligned with Earth, it would sterilize the planet as easily as a magnifying glass ignites paper. Astronomers cannot predict exactly when WR 104 will detonate. It could be in the next million years or tomorrow, but the possibility alone is enough to unsettle even the most rational minds. Gamma-ray bursts are not threats we can prepare for in the way we might defend against an asteroid. Their speed and unpredictability make them undetectable until the moment they arrive. By the time we see the light of a gamma-ray burst in the sky, the deadly radiation would already be upon us. No warning, no defense, no escape. In this sense, they represent the most brutal kind of cosmic threat, one that reduces survival not to intelligence, preparation, or technology, but to pure chance. Civilizations that happen to exist outside the aim of these cosmic rifles might live long enough to reach the stars, while those unlucky enough to be caught in the line of fire vanish without a trace, their entire histories erased in seconds. The silence of the universe may well be filled with the ghosts of worlds that were unlucky enough to be struck by these beams, entire species that flourished for millions of years, only to be obliterated in the time it takes to blink. And as we study the skies, we must ask ourselves, how long before it is our turn? If gamma-ray bursts are the universe's precision rifles, then rogue black holes are its silent assassins, drifting invisibly through the galaxy with the power to unravel entire star systems. Most black holes live anchored at the centers of galaxies, their immense gravity holding together billions of stars in stable orbits. But not all remain tethered. Some are ejected during violent stellar deaths or galactic collisions, flung into the void like cosmic bullets, traveling at speeds of hundreds of thousands of miles per hour. These rogue black holes leave no visible trace of their passage. They emit no light. They cannot be seen, and they give no warning until they are close enough for their gravity to start disrupting the worlds around them. Imagine a predator so stealthy that you could only detect its presence by the destruction it leaves behind. That is the nature of a rogue black hole. If such an object were to enter our solar system, the first signs would be subtle but catastrophic. Far out among the outer planets, Neptune's orbit would begin to wobble, imperceptible at first, but growing steadily worse. Uranus would drift from its path, pulled by an invisible hand. Then Jupiter's orbit would destabilize, sending it hurtling into the Sun or ejecting it from the solar system entirely. Without Jupiter's massive gravitational influence acting as a shield, countless asteroids and comets that it normally corrals would come raining down upon the inner planets. Mars might be slingshotted into deep space, while Earth would find its orbit distorted to the point of collapse. The tides would surge unpredictably as gravitational forces tore at the planet's crust. Earthquakes, volcanic eruptions, and tsunamis would devastate continents. Finally, as the rogue black hole drew closer, Earth itself would be stretched and twisted, the side facing the black hole experiencing far stronger pull than the far side. The planet would eventually tear apart, its atmosphere stripped, its oceans boiled into space, and its remains consumed or scattered across the void. The most disturbing fact about rogue black holes is their invisibility. Unlike asteroids or comets that reflect sunlight and can be tracked decades in advance, rogue black holes reveal themselves only when they are close enough to cause measurable disturbances. By the time we notice the gravitational anomalies they create, it would already be too late to act. No telescope could spot them from afar. They do not announce their presence with light or radiation. They are cosmic ambush predators, capable of destroying everything we know without so much as a whisper of warning. Astronomers estimate that there may be millions of these wandering black holes drifting through the Milky Way alone, relics of long-dead stars flung into the dark on chaotic trajectories billions of years ago. Each one is a silent catastrophe waiting to cross paths with a living world. Evidence of their destruction has already been observed in other systems. Astronomers have found stars wobbling inexplicably, planets ripped from their orbits and cast adrift into interstellar space, and stellar systems torn apart by gravitational forces too strong to have been caused by anything else. In some cases, entire planetary systems have been erased, leaving behind only the lonely trail of a rogue black hole's passage. This suggests that countless habitable worlds across the galaxy may have been destroyed, not by the civilizations that lived there, not by natural disasters from within, but by invisible predators passing silently through their skies. If intelligent life once flourished in these systems, it was likely extinguished without ever knowing why. The randomness of this threat makes it even more chilling. Unlike climate change, which can be studied and mitigated, or asteroids, which can potentially be deflected, rogue black holes offer no chance of preparation. They operate on timescales and trajectories so vast and unpredictable that survival depends solely on luck. Our solar system has likely been brushed by them in the past, perhaps close enough to alter climates or trigger extinctions without leaving clear evidence of their involvement. Every few million years, statistical models suggest one may pass close enough to disrupt planetary orbits. Each time we roll cosmic dice, unaware of the game, with the stakes being nothing less than the continued existence of Earth itself. In a galaxy filled with such predators, the survival of any civilization becomes even more improbable. The great filter may not be arrogance, technology, or self-destruction, but the sheer inevitability of crossing paths with one of these invisible monsters. We may spend centuries searching for signs of alien life, wondering why the stars are silent, only to realize that most civilizations are snuffed out not by their own hands, but by the gravitational jaws of rogue black holes. If that is the case, then humanity's existence may be a temporary reprieve in a universe where predators far beyond our control wander endlessly, waiting for their next victim. If rogue black holes represent silent assassins drifting unseen through space, then the heat death of the universe is a slow suffocation, a fate that does not strike in an instant, but grinds away across incomprehensible spans of time, until nothing remains. To understand this scenario, we need to recognize that every process in the cosmos depends on differences in temperature, energy, and structure. Stars shine because their cores are hotter than their surroundings. Planets orbit because gravity creates order out of chaos. Life exists because energy flows from the sun to Earth, allowing complex systems to evolve. But what happens when those differences are gone, when energy is spread so evenly across the universe that no meaningful work can be done? That is the ultimate doom predicted by the laws of thermodynamics, the heat death or maximum entropy of the universe. Entropy is a measure of disorder, and the universe's entropy has been rising since the moment of the Big Bang. At first, energy was highly concentrated, and matter organized itself into galaxies, stars, and planets. Over billions of years, however, energy has been steadily dispersing. Stars burn through their nuclear fuel, releasing light and heat into space. Black holes swallow matter and radiate faint emissions that eventually leak away. The universe, like a clock running down, is heading toward equilibrium, a state in which energy is so evenly distributed that no process, no star formation, no life, no thought can exist. The horror of heat death is not fire and destruction, but emptiness and silence, so profound that it defies imagination. In this bleak future, stars will be the first to go. Our sun, with its 10 billion-year lifespan, is ordinary compared to the tiny red dwarfs that burn their fuel with extraordinary efficiency. Some of these faint stars could shine for up to 100 trillion years, outliving everything else in the galaxy, but even they will eventually sputter out. One by one, the lights will go dark. Galaxies that now dazzle the night sky will fade into invisible husks filled with cooling embers. White dwarfs that slowly dim into black dwarfs, neutron stars that lose their heat, and black holes that stand as the final remnants of collapsed giants. The age of starlight will end, and the universe will be cast into an endless night. Even then, the story will not be over. Black holes, once thought eternal, are not permanent. They slowly evaporate through a process called Hawking radiation, shedding tiny amounts of energy over timescales so vast that the current age of the universe is less than an instant by comparison. The largest black holes at the centers of galaxies may take 10 to more years to vanish, slowly shrinking until they disappear with a final flash of radiation. When they are gone, all that will remain are scattered particles drifting through ever-expanding space, separated by distances so immense they might never encounter one another again. Matter itself will eventually decay, protons breaking down into subatomic fragments that dissolve into nothingness. The heat death is terrifying not because it is violent, but because it is inevitable and absolute. Every achievement of every civilization, every star system that ever formed, every galaxy that ever spun, will be erased not by catastrophe but by entropy's quiet hand. There will be no observers left, no records of what once existed, no memory of light or warmth. The universe will become a thin haze of photons, neutrinos, and other particles spread so thin that the concept of structure itself ceases to have meaning. Time may still exist, but it will have no direction or purpose because nothing will ever change again. The cosmos will not end with a bang, but with an eternal whisper of nothingness. Perhaps the most disturbing part of this vision is its inevitability. Unlike other cosmic threats, asteroids, rogue stars, or even gamma-ray bursts, heat death cannot be avoided through technology or luck. It is not a question of if, but when. Physics suggests that this is the final destiny of everything written into the fabric of the universe since the first second after the Big Bang. Civilizations may rise, spread to the stars, and attempt to engineer ways to delay the inevitable, but entropy always wins. The silence we see when we look into deep space may already be a preview of this fate. Countless civilizations erased, not by war or disaster, but by the slow extinguishing of starlight and the steady march toward equilibrium. If the heat death of the universe is the slow suffocation of existence, then vacuum decay is its instantaneous execution. A nightmare so complete that it erases not just matter and energy, but the very rules that allow reality to exist. Most people think of space as an empty void, a silent backdrop against which stars and galaxies play out their lives. But physics tells us something stranger. The vacuum of space is not truly empty at all. It is a seething field of invisible energy, the foundation upon which every particle, every force, and every atom depends. This vacuum state defines the constants of nature, the properties of matter, and the interactions that allow stars to shine and life to emerge. Yet, there is a chilling possibility whispered in equations. The vacuum we live in might not be the true ground state of reality, but only a temporary plateau known as a false vacuum. Imagine a ball resting in a shallow dip on a hillside. It seems stable, but with the slightest push it could tumble into a deeper valley below, never to return. If our universe is perched on such a false vacuum, then at any moment, a quantum fluctuation or high-energy event could cause a tiny region of space to tunnel into a lower energy state. That event would create a bubble of true vacuum, a new reality with different laws of physics that would expand outward at the speed of light, consuming everything in its path. There would be no warning, no time to react, no defense. One instant, Earth would be as it is now, filled with life, thought, and history. The next instant, the very atoms making up our bodies would unravel as the rules governing them were rewritten. Inside the bubble of true vacuum, the universe would be utterly alien. The constants of nature could shift, altering the strength of gravity, electromagnetism, or the nuclear forces. Chemistry, as we know it, might become impossible. Atoms could fall apart or bind together in ways unrecognizable to us. Stars would cease to shine, not because they ran out of fuel, but because fusion itself might no longer work. Perhaps matter would dissolve entirely, leaving behind only exotic particles drifting in a featureless void. Or perhaps new structures would emerge, incomprehensible to anything that came before. But one thing is certain: whatever new reality the bubble contains, it will not be compatible with us. Humanity, Earth, and every trace of our existence would vanish, erased in less than a heartbeat. What makes vacuum decay uniquely terrifying is its stealth. Unlike an asteroid strike or a supernova, which give warning signs, a vacuum collapse offers no clues until it arrives. Because the bubble expands at the speed of light, the destruction and the first evidence of its approach would arrive simultaneously. We would never see it coming. One moment, the night sky would be filled with familiar stars, and in the very next instant, those same stars would be gone, rewritten into something else. Even distant galaxies would not survive. The entire observable universe would eventually be consumed, every last corner transformed into the lower energy state of the true vacuum. Scientists have debated whether our universe is stable or metastable. The discovery of the Higgs boson in 2012 provided tantalizing hints that the Higgs field, the energy field that gives particles their mass, might sit in a precarious position, not at the lowest possible energy, but balanced delicately on a false floor. If true, then the threat of vacuum decay is not just theoretical but inevitable over cosmic timescales. The trigger could be random quantum tunneling, which might take billions of years, or it could be catalyzed by extreme events such as collisions of black holes or even high-energy experiments. Some physicists once worried that human particle accelerators might inadvertently trigger vacuum collapse, Though most calculations suggest the universe is already bombarded with higher energy cosmic rays without incident, still, the fear lingers. What if one day, somewhere in the cosmos, such a fluctuation has already occurred, and the bubble of true vacuum is even now racing toward us, unstoppable and unseen? The existential dread of vacuum decay lies not only in its inevitability, but in its erasure of meaning. Other apocalypses, asteroids, black holes, supernovae, destroy world civilizations or galaxies, but they leave the framework of physics intact. They operate within rules we understand. Vacuum decay does not. It rewrites the very script of reality, creating a new play where the old one never happened. If it occurs, there will be no survivors, no memories, not even the possibility of anyone in the future reconstructing what was lost. It is not simply death on a cosmic scale, it is the annihilation of context itself, the replacement of everything we know with something we cannot comprehend. In contemplating the silence of the universe, vacuum decay offers a chilling possibility. Perhaps civilizations elsewhere reached heights of knowledge and power only to be obliterated, not by their own folly or cosmic accidents, but by reality itself turning against them. No matter how advanced a species becomes, no matter how far it spreads, a vacuum collapse erases it all in an instant. This could explain why the stars seem so quiet. The universe may be constantly rewriting itself, leaving no trace of those who came before. If that is true, then our existence is not just fragile. It is a fleeting flicker in a reality that can vanish without reason, without warning, and without mercy. If vacuum decay represents the silent rewriting of reality itself, then the fury of our own star reveals a far more immediate and personal threat. The sun, which sustains all life on Earth, has the potential to destroy our technological civilization in mere hours. For billions of years, the sun has appeared stable, a dependable beacon that provides warmth, energy, and the conditions for life. Yet, beneath its surface lies a seething nuclear inferno, a roiling sea of plasma where magnetic fields twist, snap, and hurl unimaginable amounts of energy into space. This hidden violence is not distant speculation. It has struck Earth before, and when it does again with full force, our modern world may not survive. Every 11 years, the sun's magnetic cycle reaches a peak, a period known as solar maximum. During these times, its surface becomes scarred with dark sunspots, regions of intense magnetic activity. These tangled magnetic fields can suddenly snap and reconnect in violent outbursts, called solar flares, releasing energy equivalent to billions of nuclear bombs in a matter of minutes. Solar flares bombard Earth with streams of high-energy photons, X-rays and ultraviolet light that ionize the atmosphere and disrupt communications. But the true danger arrives with their monstrous companions, coronal mass ejections, or CMEs. These are colossal bubbles of plasma and magnetic fields, larger than planets, launched from the sun's surface at millions of miles per hour. When a CME slams into Earth, it compresses our magnetic field and unleashes a geomagnetic storm that electrifies the very fabric of our planet. The most famous example came in 1859, an event known as the Carrington event. Telegraph wires sparked and burned. Operators were shocked by surging currents, and auroras lit the skies as far south as the Caribbean. Yet the world of 1859 had no satellites, no global power grids, no internet. Civilization continued largely unaffected once the telegraph lines were repaired. If an equivalent storm struck today, the consequences would be catastrophic. Power grids across continents could collapse as transformers overloaded and burned out. Satellites would be fried, silencing GPS, communication systems, and weather forecasting. Air travel would be grounded, financial systems would fail, and within hours, modern civilization would be thrown into chaos. Recovery would not be quick. Replacing transformers and satellites could take years, leaving society crippled in a world that no longer knows how to function without electricity. Smaller solar storms happen often, but the sun's potential for truly catastrophic outbursts remains underestimated. Studies of ice cores and tree rings reveal spikes of radioactive isotopes created by ancient solar flares, far larger than anything in recorded history. In 2012, Earth narrowly missed a solar storm of Carrington scale by just a few days. If that CME had struck us directly, global infrastructure would have been devastated. Scientists warn that such events occur once every century or two, meaning we are overdue for another. Unlike other cosmic threats, this one is not hypothetical, it is inevitable. The only uncertainty is when the terrifying part of solar fury lies in its speed and unpredictability. Asteroids may be tracked years in advance, giving humanity time to prepare. Supernovas occur far away, and their signals can be studied before their effects reach Earth. But solar storms give little warning. A CME launched from the Sun can arrive at Earth in less than a day. And even with the best monitoring systems, humanity may have only hours to brace for impact, and bracing may not be enough. Power grids are global and interlinked. A collapse in one region can cascade across entire continents. Satellites are packed with delicate electronics, vulnerable to radiation bursts, and human dependence on digital technology has never been greater. In an instant, society could be hurled back to a pre-industrial age, not by war or politics, but by the very star that made civilization possible. It is unsettling to imagine that the glowing disk in the sky, the one we associate with warmth, life, and stability, is also a ticking time bomb. Humanity depends on the sun for survival, but we are also at its mercy. A single storm, invisible to the naked eye, could unravel centuries of progress. The Earth has endured countless solar tempests before, but never has there been a species so dependent on fragile technologies as we are today. Each sunrise carries not just light, but the quiet possibility that tomorrow's dawn could bring the beginning of our greatest crisis. The danger is not distant, not theoretical, it is above us, constant, waiting for the next magnetic twist to unleash chaos. The question is not whether the sun will strike us with a catastrophic storm again, but whether we will be prepared when it does. Humanity has grown accustomed to thinking of threats as external: asteroids, black holes, alien invasions. But sometimes the most devastating enemy is the one that nourishes us daily. We live in the glow of a star that can both cradle and kill, a paradox written into the very design of the cosmos. And as we look toward the future, we must ask ourselves, will we adapt in time, or will we be another casualty in the endless cycle of creation and destruction written in the fire of the stars? If vacuum decay represents the silent rewriting of reality itself, then the fury of our own star reveals a far more immediate and personal threat. The sun, which sustains all life on Earth, has the potential to destroy our technological civilization in mere hours. For billions of years, the sun has appeared stable, a dependable beacon that provides warmth, energy, and the conditions for life. Yet, beneath its surface lies a seething nuclear inferno, a roiling sea of plasma where magnetic fields twist, snap, and hurl unimaginable amounts of energy into space. This hidden violence is not distant speculation. It has struck Earth before, and when it does again with full force, our modern world may not survive. Every 11 years, the sun's magnetic cycle reaches a peak, a period known as solar maximum. During these times, its surface becomes scarred with dark sunspots, regions of intense magnetic activity. These tangled magnetic fields can suddenly snap and reconnect in violent outbursts called solar flares, releasing energy equivalent to billions of nuclear bombs in a matter of minutes. Solar flares bombard Earth with streams of high-energy photons, X-rays and ultraviolet light that ionize the atmosphere and disrupt communications. But the true danger arrives with their monstrous companions, coronal mass ejections, or CMEs. These are colossal bubbles of plasma and magnetic fields, larger than planets, launched from the sun's surface at millions of miles per hour. When a CME slams into Earth, it compresses our magnetic field and unleashes a geomagnetic storm that electrifies the very fabric of our planet. The most famous example came in 1859, an event known as the Carrington event. Telegraph wires sparked and burned. Operators were shocked by surging currents, and auroras lit the skies as far south as the Caribbean. Yet the world of 1859 had no satellites, no global power grids, no internet. Civilization continued largely unaffected once the telegraph lines were repaired. If an equivalent storm struck today, the consequences would be catastrophic. Power grids across continents could collapse as transformers overloaded and burned out. Satellites would be fried, silencing GPS, communication systems, and weather forecasting. Air travel would be grounded, financial systems would fail, and within hours, modern civilization would be thrown into chaos. Recovery would not be quick. Replacing transformers and satellites could take years, leaving society crippled in a world that no longer knows how to function without electricity. Smaller solar storms happen often, but the sun's potential for truly catastrophic outbursts remains underestimated. Studies of ice cores and tree rings reveal spikes of radioactive isotopes created by ancient solar flares far larger than anything in recorded history. In 2012, Earth narrowly missed a solar storm of Carrington scale by just a few days. If that CME had struck us directly, global infrastructure would have been devastated. Scientists warn that such events occur once every century or two, meaning we are overdue for another. Unlike other cosmic threats, this one is not hypothetical. It is inevitable. The only uncertainty is when. The terrifying part of solar fury lies in its speed and unpredictability. Asteroids may be tracked years in advance, giving humanity time to prepare. Supernovas occur far away, and their signals can be studied before their effects reach Earth. But solar storms give little warning. A CME launched from the sun can arrive at Earth in less than a day, and even with the best monitoring systems, humanity may have only hours to brace for impact. And bracing may not be enough. Power grids are global and interlinked. A collapse in one region can cascade across entire continents. Satellites are packed with delicate electronics, vulnerable to radiation bursts, and human dependence on digital technology has never been greater. In an instant, society could be hurled back to a pre-industrial age, not by war or politics, but by the very star that made civilization possible. It is unsettling to imagine that the glowing disk in the sky, the one we associate with warmth, life and stability, is also a ticking time bomb. Humanity depends on the sun for survival, but we are also at its mercy. A single storm, invisible to the naked eye, could unravel centuries of progress. The Earth has endured countless solar tempests before, but never has there been a species so dependent on fragile technologies as we are today. Each sunrise carries not just light, but the quiet possibility that tomorrow's dawn could bring the beginning of our greatest crisis. The danger is not distant, not theoretical, it is above us, constant, waiting for the next magnetic twist to unleash chaos. The question is not whether the sun will strike us with a catastrophic storm again, but whether we will be prepared when it does. Humanity has grown accustomed to thinking of threats as external asteroids, black holes, alien invasions, but sometimes the most devastating enemy is the one that nourishes us daily. We live in the glow of a star that can both cradle and kill, a paradox written into the very design of the cosmos. And as we look toward the future, we must ask ourselves, will we adapt in time, or will we be another casualty in the endless cycle of creation and destruction, written in the fire of the stars? If the sun is the unpredictable tyrant that could cripple us without warning, then asteroids and comets are the silent assassins of the cosmos. Ancient relics of creation wandering the void, each one a potential world ender. The Earth's history is written in scars, craters scattered across continents, seas and hidden beneath forests, silent evidence that the universe has never stopped trying to destroy us. 66 million years ago, one such visitor, a mountain-sized asteroid, struck what is now the Yucatan Peninsula with the force of several billion nuclear bombs. In a single day, the age of the dinosaurs ended, and a new chapter for mammals and eventually humans began. But the brutal truth is that nothing about that event was unique. We live in a cosmic shooting gallery, surrounded by tens of thousands of objects, large enough to annihilate cities, continents, or entire civilizations, and our detection systems cover only a fraction of them. Asteroids are pieces of rock and metal left over from the solar system's formation, orbiting the sun in patterns that occasionally intersect with Earth's path. Some are as small as pebbles, while others stretch for miles. Comets, by contrast, are icy time bombs, massive frozen bodies that dwell in the distant Oort cloud until gravitational nudges from passing stars or galactic tides hurl them inward at terrifying speeds. Their approach is far more unpredictable than asteroids, and their velocities make them exponentially more destructive. To put it into perspective, while an asteroid might strike Earth at 30,000 bmsabr, a long-period comet could slam into us at over 100,000 bmsabr, multiplying its destructive energy many times over. The kinetic energy of these objects is staggering. Even a rock only a few hundred feet wide could unleash destruction on a scale humanity has never seen. The Tunguska event of 1908, caused by an object no more than 200 feet across, flattened 800 square miles of Siberian forest, releasing a force greater than thousands of nuclear bombs. If such an impact occurred over a city, millions would die instantly, and the economic shockwaves would ripple across the planet. Larger asteroids, a mile across or more, could throw so much dust and debris into the atmosphere that sunlight would be blocked for years, collapsing agriculture and triggering global famine. Civilization itself could collapse within months, not from the direct impact, but from the slow starvation of billions. What makes the threat so terrifying is not just the scale of destruction, but the lack of warning. NASA and other agencies track thousands of near-Earth objects, but they admit that we have only mapped about half of those larger than 40 meters, the minimum size capable of destroying a region the size of a small country. Smaller yet, still dangerous objects slip past unnoticed all the time. In 2013, a meteor roughly 60 feet wide exploded in the skies over Chelyabinsk, Russia, injuring over 1,000 people and shattering windows across 6 cities. Nobody saw it coming. The universe does not announce its intentions. It simply throws its stones, and we are left to hope none are aimed at us. Comets represent an even more disturbing danger. While asteroids generally follow predictable orbits, we can model decades into the future. Comets arrive suddenly from the outer reaches of the solar system, their trajectories altered by unseen gravitational interactions. A long-period comet could give us only months or even weeks of warning before impact, and because they strike at higher velocities and carry far more energy, their potential for devastation is unmatched. Some scientists believe that comets, not asteroids, were responsible for several of Earth's mass extinction events. If true, then our fragile existence is at the mercy of icy wanderers we cannot yet detect until it is too late. The silence of the skies may not comfort us, but should terrify us. Right now, over 28,000 near-Earth asteroids, larger than a football field, are known, and countless more remain hidden in the glare of the sun, invisible to our telescopes. Some travel in elongated orbits that intersect Earth only once every few centuries, meaning they could strike without warning. The unsettling truth is that Earth has never been safe, and survival has always been a matter of luck. Humanity has only recently gained the ability to see some of these cosmic bullets before they strike, but our defenses remain primitive. The best we can do is nudge them off course, and even that technology is experimental. If a large asteroid were discovered today on a collision course with Earth, and the impact was less than a decade away, there is little chance we could prevent it. The dinosaurs never saw their doom in the sky, but we can. We can look up, measure, and calculate, yet knowledge does not guarantee safety. Every day, as we marvel at the stars, we forget that the same night sky hides the very weapons that could erase us in an instant. Asteroids and comets are not science fiction. They are inevitabilities, ticking clocks scattered across the solar system. The only question is when one of them will find us again, and whether humanity will still be here to bear witness to the next crater carved into Earth's fragile surface. If asteroids and comets are the stones flung across the solar system, then rogue black holes are the invisible predators stalking silently through the galaxy, unseen, unstoppable, and utterly indifferent to our existence. A black hole is already one of the most terrifying objects imaginable, a place where gravity grows so strong that even light cannot escape, where the laws of physics break down at the event horizon, and where time itself slows to a crawl before vanishing into darkness. Most black holes stay anchored to the centers of galaxies, where their immense mass helps to hold billions of stars in orbit. But not all remain tethered. Some are flung free during violent supernova explosions or gravitational encounters with other massive objects, set loose to wander the galaxy forever. These are the rogue black holes, cosmic predators moving silently through space, invisible until they pass too close to a star system. They are the sharks of the cosmic ocean, and one could be swimming toward us even now without leaving the faintest trace. Unlike asteroids or comets, rogue black holes give no warning. They emit no light, no radiation, no glow that could betray their presence. The only way to detect them is by observing their gravitational influence on nearby objects. If a rogue black hole passed within a few light years of our solar system, the first signs might be subtle. Neptune's orbit shifting, Uranus drifting slightly off its predicted path, comets from the Oort cloud beginning to rain inward in chaotic swarms. At first, astronomers might attribute these anomalies to errors in measurement. But as the black hole crept closer, its influence would grow undeniable, pulling planets into eccentric orbits, destabilizing the delicate balance of our solar system, and turning the sky into a clock counting down to catastrophe. Imagine what would happen if such a black hole came close enough to Earth. Its gravity would not pull us in all at once. Instead, it would stretch and distort everything, unleashing tidal forces powerful enough to tear continents apart. Earthquakes would ripple across the planet, volcanoes would awaken, and tsunamis would sweep across oceans as the planet's crust buckled under gravitational stress. The atmosphere itself could be stripped away, boiling off into space, while the oceans evaporated into nothing. Eventually, Earth would be pulled apart completely, shredded into a stream of debris spiraling into the black hole's dark maw. No trace of our civilization would remain. Not ruins, not ashes, not even dust. Only particles scattered into the void, consumed by the event horizon, never to return. Astronomers estimate that our galaxy alone contains millions of rogue black holes. Each one is the remnant of a massive star that died in a violent explosion, kicked away by gravitational recoil like a cosmic billiard ball. They drift silently, pulled only by the faint gravitational tides of the galaxy. Some move at hundreds of thousands of miles per hour, making them virtually impossible to track. In fact, one such black hole was recently detected for the first time, wandering through the Milky Way about 5,000 light-years from Earth. An invisible giant that revealed itself only because it bent the light of background stars as it passed in front of them. If even one of these nomads wandered within a few dozen light-years of Earth, the consequences could cascade across our solar system for millions of years, leaving us powerless to prevent the slow-motion destruction of everything we know. What makes rogue black holes even more terrifying is their unpredictability. Unlike asteroids, which can be tracked, or solar storms, which follow cycles, rogue black holes follow no schedule and no path we can anticipate. They are hidden in the dark, detectable only by chance, and by the time we notice their presence, it may already be too late. Humanity could wake up one morning to the discovery that the orbits of the outer planets no longer make sense, that the solar system itself is being torn apart by a gravitational predator we cannot even see. By then, the countdown to our end would already have begun. It is sobering to realize that we live in a galaxy littered with these silent destroyers, and the only thing keeping us safe is chance. Earth has likely encountered rogue black holes before in its history, their distant passages perhaps triggering climate shifts or even mass extinctions without leaving clear evidence of their cause. We might already owe some of life's great evolutionary resets to these invisible predators. The truth is that the galaxy is not a safe, orderly place, but a battlefield of forces far beyond our control, and black holes are the most ruthless players of all. When we look at the night sky, we see stars twinkling with apparent serenity. But lurking in the darkness between them are unseen monsters that could erase us without effort or warning. A rogue black hole does not need to strike Earth directly to destroy us. It only needs to pass close enough to destabilize the solar system, to turn our orderly orbits into chaos. We exist at the mercy of predators we cannot see, predators that drift silently, waiting for the random encounter that could end everything. The story of cosmic threats and existential dangers is not simply a tale of doom, but a reflection of the fragile position we occupy in the vastness of space. From the environmental collapse we risk creating on our own planet, to the silent menace of rogue black holes drifting invisibly through the galaxy, the universe constantly reminds us of how precarious survival truly is. Every chapter of this story, whether it is the great filter, the mystery of dark matter, the inevitability of dark energy, or the catastrophic potential of gamma-ray bursts, paints the same haunting picture. We are temporary guests in a cosmos that does not bend to our needs, our dreams, or our ambitions. Civilizations may rise and fall, species may flourish and vanish, but the universe continues its march toward entropy, indifferent to everything that unfolds within it. Yet within that indifference lies both terror and beauty, because the very forces that threaten to erase us are also the forces that created us in the first place. The same black holes that can swallow worlds are the engines that shaped galaxies. The same comets that can devastate Earth may once have delivered the water and organic materials that made life possible. The violence of the universe is not separate from life, it is its foundation. When we contemplate our place in this story, it becomes clear that survival is not guaranteed, and perhaps it never was. 99% of all species that have ever lived on Earth are now extinct, most erased, not by human hands, but by forces far beyond their comprehension or control. Extinction is not the exception, it is the rule. Humanity's unique ability to understand the threats around us does not grant immunity, but it does give us something no other species has had before: the ability to anticipate, prepare, and maybe, just maybe, defy the odds stacked against us. Whether we succeed depends not on conquering nature, but on recognizing the limits of our control and the urgency of our responsibility. The silence from the stars may already be telling us the outcome. Perhaps countless civilizations have emerged, reached the peak of their technological abilities, and then succumbed to their own filters, destroyed by their own excesses, silenced by environmental collapse, or wiped away by random cosmic catastrophes before they could spread beyond their home planets. If that is true, then humanity faces the same test, and the next century may decide whether we are destined to join the chorus of silence or stand as one of the rare survivors. To pass this test, we must master not only technology, but also foresight, humility, and the capacity to act as guardians of our fragile world. The universe's endgames, whether the slow freeze of heat death, the tearing apart of the Big Rip, or the sudden annihilation of vacuum decay, may render everything temporary. No matter how advanced we become, even if we spread to billions of stars, these ultimate dooms remain beyond escape. But the fact that everything ends does not make our existence meaningless. On the contrary, it makes it precious. The brevity of our moment in the cosmic story gives weight to everything we create, every connection we form, every step we take to preserve life and extend its reach. Meaning does not come from permanence, but from presence. So as we look into the night sky and see both beauty and terror, the conclusion is not that we should despair, but that we should awaken. The same universe that can erase us without hesitation has also given us the chance to reflect, to question, and to imagine. That perhaps is our greatest defense. Not strength, not control, but awareness. To live with the knowledge of our fragility is to live with urgency. And to live with urgency is to recognize that while we cannot control the universe, we can shape how we respond to it. Our story is not yet finished, and the silence of the cosmos is not yet our fate. The question that remains is whether we will use our brief window of awareness to secure a future beyond Earth, or whether we will let the weight of inevitability lull us into complacency. In the end, survival may be improbable, but significance is certain, because even in the face of annihilation, to have existed, to have wondered, and to have reached for the stars is itself a victory against the void.